Welcome back to 1.3 Equations of Lines and Planes. Today we will be learning about lines and planes in 3D, or in R3, which is something that I'm going to use. I'm going to use this notation, R2, R3. R2 is the XY plane. Why do we call it R2? Because it's the real numbers, but you have two digits. You have two possible pairs of numbers, so it's an ordered pair, right? Where this is a real number and this is another real number, so that's why we call it R2. I don't know why it's 2 on top. I think it should be 2 on the bottom, in fact, because that would make more sense, because this might be confused with squared. It's not R squared, it's R2. So R2, in R2 we have the notion of slope, right, which is the change in y over change in x. That's how we are able to tell direction, right? It's not very clear. It's not the most clear direction that we could tell, and to be able to make that direction clearer, we use parametric equations in pre-calculus to indicate that whether or not we're going up this hill or going down the hill. But slope is kind of a preliminary measure, right? Now, how are we able to fit this notion of slope in the 3D world that we're going to have to work in right now? Well, we're going to be able to fit this notion of slope by completely removing it and by substituting with parametric equations or vector equations, right? So in R3, since there's no two values that we can compare to give us a ratio like slope, we have to use parametric equations, and these are the equations of the form. Sometimes you will also see them like this, right? This is an important form right here. This is how I will normally write my vector equations of the line, of a line, and it's not very long, but as you can see, the vector equation and the parametric equation is pretty similar. The vector equations are just the parametric equation is taking out of the vector equation. So this is your vector equation right here, a1t plus b1. That's just the x, and well, right there, that's the first component of the vector. That's the x, and this is the y. And my voice is a little bit crinkly right now, so bear with me here, but that's the z. So there you go. That's how you write your lines in a parametric and a vector form. But there's also another form that the book wants me to teach you. I don't think that this form is useful at all, and it will not be on my test, but it's here, so you have to learn it. And the other form is the symmetric equations. So if you have this one line right here, x equals a1t plus b1, you can actually solve for t, right? And since every single one of them have t, you can set them equal to each other. So what happens is you get x minus b1 over a1 plus y minus b2 over a2 plus, or not plus, equals z minus b3 over a3, right? So what you could do here is you could do, well, t equals x minus b1 over a1, and then you will be able to solve t equals y minus b2 over a2, and then t equals z minus a3 or b3 over a3. And since they're all equal to each other, or equal to t, since they're all equal to t, they're equal to each other. There you go. So let's do the example right now. Last video was quite long, so I just want to kind of go through this video in a moderate pace and not make you guys bored to death with my examples. So we're gonna go quick, and you should know that after every example, if you think that you know it, you should not wait for me to do the example. You should do the example by yourself, and then check later on if you are correct or not. Just skip a couple seconds, 10-15 seconds. The right arrow on your keyboard should be enough. Just press it a few times, and if I talk like this, if I talk a lot like this, then just press it a few more times and it should go. Find the equation of a line that passes through, I am sorry, this is wrong notation. It's supposed to be or brackets, or parentheses, like this. So pass through these 2 points, P 195, Q negative 3, negative 8, 0. Now, in order to make a line like this, we need two things. Two very important things is a slope and a point. And we have a point. We have 2 points, in fact, and we can actually make a kind of a vector, right? A slope. But slope in R3 is a vector, so we can make a slope out of this. So our vector is I'm just going to take Q minus P. You can take P minus Q. It's not a big deal, but I'm going to take Q minus P, and this is equal to negative 3 minus 1 is, well, negative 4, negative 17, negative 5. There you go. So that's our vector. Now we can just take one of the points. So the equation is 195 plus t times negative 3, negative 8, 0. Or actually, we could also use the vector notation if we are putting this as a function. And this is the notation for a function. It's usually R. Sometimes it's different, but we put a line through it like this. Or we could also just bold it, right? But obviously there's no way to bold it. There's no way to bold when you're writing like this, except maybe use like a thicker one. But I'm not going to do that. So let's keep going. Now, 3 vocabulary words that I'm going to have to write down, I guess you could say. I forgot to write them down. What is parallel, intersecting, or skew? Well, intersecting is quite obvious. Intersecting is if 2 points or if 2 lines cross each other. That's literally it, right? If 2 lines cross each other at a point. That's intersecting. Parallel is if 2 lines don't cross each other and this is very important, are at a fixed distance away from each other. There you go. And skew is if 2 lines don't cross each other, or let me put a line. If 2 lines don't cross each other, but they are not a fixed distance away from each other at every point. So it's kind of like this. Intersecting, well, if I draw down a plane right here, intersecting, I'm pretty sure you guys can just, there, that's intersecting. Parallel is something like this. If you have a line right here, and then if you have a line maybe down here, right here, that's parallel. Skew is like if you have a line right here up top, but then you have another line coming right here at the bottom, but they're not going to intersect. They're not intersect because they're not in the same plane, but they're still, you know, not going to, or they're still not equidistant away from each other at all points. So if you take a point like right here, and then if you take a point like right here, well, the closest point, well, actually, let me rephrase that. If you take a point right here, the closest point to this point is not the same as the closest point to this point, right? Whereas in parallel lines, for example, or I've already undone everything, but in parallel lines, the closest point to every single point is the same distance away. It's always the same distance away. In skew, that's not the case. So how we're going to be able to realize that? How are we going to be able to do calculations to determine whether or not it's one of these 3? So if it's intersecting, well, so we're going to work out values for t and s. right? We're going to work out values for t and s. Let's do that right now. So I'm going to use x and z, because if we use x and y, stuff happens, and I don't want stuff to happen. So we're going to use x and z, and what you want is the same x and the same z, right? If you visualize it, if two lines are intersecting, they have to have the same x, y, and z coordinates. So we're going to set the x's equal to each other. 3 plus 2t equals 1 plus 4s, and the z's equal to each other, right? I would use x and y, but it's not very nice in this case, right? And then we're going to simplify these. We're going to make them a little bit simpler. We're just going to move. I'm just going to put a line here. It doesn't mean anything. It's not like I'm not putting plus or minus, so it doesn't mean anything. But it's subtract 3 from both sides, so it becomes 2 plus 4s, and then 3t equals 3 plus 5s, right? And then I'm going to multiply this top one by 3 and bottom one by 2. So 6t equals minus 6 plus 12s, and then 6t again equals 6 plus 10s. And then what I am going to do is I am going to subtract the two equations. So we'll get 0. See, now I'm actually adding the subtraction. We have to subtract the entire equation, minus 12, and then plus 2s, I think. Am I right? I hope I am. So s is 6. S becomes 6. So if s is 6, we add it back into here. I'm not going to do you can do the calculation by yourself, but 6 times 4 is a big number. 6 times 4 is what? I should know this. 24 minus 2 is 22, and then t would give you 11. T would be 11. So if you put it back into this equation, you'll get 25 equals 25, and if you put it into this equation, you will get 34 equal 34, right? So they are intersecting. However, the real test is you have to put it back into y. You have to put the t and s into y. And if that also works, then they are intersecting. If it doesn't, then we have to go to the other two. So t is equal to 11. Well, 4 minus 11 will give you, well, y equal negative 7. And then 6, 3 minus 2 times 6, that'll give you a negative 9. So they're not the same. Since they're not the same, they're not intersecting. You have to do all of that work to find that they're not intersecting. It's a lot of work, but it's worth it. So if they're not intersecting, then now what? Now what we do is we compare their vectors. So if we can rewrite line 1, L1, we can rewrite that as, well, 3, 4, 1 plus t times 2, negative 1, 3. And then L2, we can rewrite that as 1, 3, 4 plus t times 4, negative 2, 5. So we have to compare this vector right here. This is like a slope vector. Now the reason why I keep saying slope even though it's a vector is in 2D, in R2, slopes that are parallel or lines that are parallel have the same slope, right? In R3, vectors that are parallel are scalar multiples of each other. So scalar multiple means that if I multiply this by a real number, if I multiply this by a real number, real scalar, I have to be able to get this, right? There has to be a solution. Now in this case, there's no solution. Why? Because if I multiply this, the number it takes for me to get from 2 to 4 is 2. The number it takes for me to get from negative 1 to negative 2 is also 2. But the number it takes for me to get from 3 to 5 is 5 over 3, which is not 2, right? So because they are not in proportion, then this is not parallel either. So the only designation they could be left is skew. So these lines are skew. Next one, this is the symmetric equations this time. So x over 1 equal y minus 1 over negative. I don't like these equations. These equations aren't cool. However, we're going to have to work with them anyways. So we're going to rewrite them as parametric equations. So let's do that right now. So x over 1 is just x equals t. Yeah, it's just x equals t. And then y minus 1 over negative 1 is y equal, or y, well, y minus 1 over negative 1 equal t. So y equal negative t. So y equals negative t plus 1. Right? So y is equal to negative t plus 1. And then z is equal to, well, I'm sorry, my brother's really mad at something. So the bottom number, and then the opposite of the top number, so plus 2, right there. X equal 2t plus 2, y equals minus 2t plus 3, and z equals 7t. I'm sorry. Actually, for the sake of this, I'm going to change it to s so that we can actually solve an equation. So 2s plus 2 minus 2s plus 3. Now what am I gonna use? I'm gonna use the x and the z's again. Why? Because there's actually one. Oh, I'm sorry. There's one. Oh my gosh. Oh my gosh. So there is one pair, I guess you could say, x. This, when you set these equal to each other, there's only one coefficient. So I don't have to like move it around as much. I might still will though, so I'm going to probably still move it around a lot. I just need to get this thing out of the way. This is annoying. I'm gonna get it out of the way right now, and then I will start. So I guess you could do a quick inspection to see if this is parallel or not, right? We have 1 right here, we have negative 1 right here, and we have 3. 1, negative 1, 3. Short, okay, that's our vector, that's our slope vector. 2, negative 2, 7. There's probably, you probably could sense there's something wrong with that, is because there is something wrong with that. This is supposed to be 6 if it's parallel, it's not. So it is not parallel, but let's see if it's intersecting or skew again. So let's do it. So t is equal to 2s plus 2. 3t plus 2 is equal to 7s. So we'll just use the t, so we can subtract 2 from the other side. So we'll have something like t is equal to 2s plus 2 still, but 3t is equal to 7s minus 2. We can multiply this by 3. 3t is equal to 6s plus 6. And 3t is equal to 7s minus 2. And if you are quick on your feet, you'll realize that s equals 8. But we will work that out. So negative s plus 8 is equal to 0. So subtract this equation from this equation, and then s equal 8. So if s is equal to 8, then what is t? Well, t equals to s plus 2, so t is 18, right? Now, we put it into y. If it works, then the two equations are, well, two equations are intersecting. And which point do they intersect at? They intersect at x, y, z. But if it doesn't work, then it doesn't work. If it doesn't work, then they are skew. So let's put, okay, I'm just going to put t down here first. 2 times 8 plus 2 is 18. So y is equal to negative t plus 1. Y is equal to negative t, oh, I'm sorry, negative 2, okay. Y is equal to negative t plus 1. So negative t plus 1 is negative 18 plus 1, which is, I hope I didn't do this wrong. I really hope I didn't. Negative 18 plus 1 is 17. So you will have y is equal to negative 17 here. Now y is equal to negative 2s plus 3. Negative 2s, well, s is 8. S is 8. So negative 2s plus plus 3 is negative or negative 13. So 17 and 13 not equal to each other, so this is also a skew line. I should probably do some examples where they aren't skew lines, but it just happens that they are skew lines, and I can't really do anything about it. If you want to do 20, which I have crossed out these, if you want to do 20, you can do 20 as well. I can tell you that, stop right now if you want to do 20. I can tell you that they are parallel. So these are parallel. I can just tell you by inspection. I don't know what 21 is though, so I have to do that by myself if I want to know. If you figure out a mistake, like what I did was a mistake, then please tell me, because I am not perfect. I wish I was. So let's keep going.